Somewhere out there, in the unimaginable darkness, is a person who looks exactly like you. They have your memories, your scars, your hopes. Right now, they might be making a cup of coffee, just like you did this morning. Or perhaps they're making a different choice, a choice you considered but didn't take. This isn't science fiction. This is a direct and deeply unsettling consequence of our best understanding of the universe. The idea that you are unique is a comforting illusion. The reality, if our universe is truly infinite, is that you are not one, but one of many. To understand how this is possible, we don't need to break the laws of physics. We just need to follow them to their most logical and terrifying conclusion. And once you see it, you can't unsee the endless sea of your own reflections staring back from the void.
The word infinite gets thrown around a lot, but in cosmology, it has a very specific meaning. When we say the universe might be infinite, we're talking about its geometry. Is it flat? Think of it like an endless sheet of paper. If you and a friend start walking in parallel lines, you'll stay parallel forever. You'll never meet. This is what our best measurements, like those from the Planck satellite mapping the cosmic microwave background, suggest. A flat universe doesn't curve back on itself. It just keeps going. There's no edge. There's no center. It is a boundless expanse. Now, it's important to distinguish this from our observable universe. That's a different concept entirely. That's our cosmic bubble, the part we can see. But the evidence points to the idea that beyond our bubble, the show goes on forever.
So, if the universe is infinite, why can't we see forever? The reason is the speed of light, the ultimate cosmic speed limit. The universe is about 13.8 billion years old. That means light from the most distant objects has had 13.8 billion years to travel to us. Anything farther away than that, the light simply hasn't reached us yet. This creates a sphere of visibility around us, with us at the center. This is our observable universe. Its edge isn't a physical wall, it's a horizon of time. It's the same for any observer anywhere else in the cosmos. They would have their own observable bubble. The critical point is this: there is no reason to believe the universe stops at the edge of our vision. It's like being on a boat in the middle of the ocean. You can see to the horizon, but you know the ocean continues far beyond it. Our physics suggests the universe does too.
Now we have our first ingredient, an infinite space. The second ingredient is more counterintuitive. It's the fact that matter, the stuff that makes you, me, and everything we see, is built from a finite set of parts, arranged in a finite number of ways. Think about it. You're made of atoms. Those atoms are made of protons, neutrons, and electrons.
Those are, in turn, made of quarks. While the combinations are vast, they are not infinite. There's a limited number of ways you can arrange these fundamental particles within a given volume of space to create something stable and physically possible. Your body, for example, occupies a certain volume. The number of particles in it and the number of states those particles can be in, their position, their energy, their spin, is an absolutely enormous number, but it is not an infinite one. Let's use an analogy. A deck of 52 cards. The number of ways you can arrange that deck is huge. It's 52 factorial, a number with 68 digits. It's so large that if you shuffled a deck every second since the beginning of the universe, you wouldn't even be close to seeing every combination. But here's the key. The number is finite. If you had an infinite amount of time to shuffle, you would eventually repeat an exact sequence. You'd have to. Now, scale that up. Instead of a deck of cards, think of the arrangement of all the particles in the volume of space you occupy. The number of possible arrangements is stupefyingly large, but it's still finite. It's just a much, much bigger deck of cards. This is where it all comes together. We have two facts. Fact one, the universe is, in all likelihood, infinitely large. It's an infinite container. Fact two, within any given volume of space, there is a finite number of ways to arrange matter and energy. You have a finite number of things you can put into an infinite number of boxes. What's the logical result? Repetition. It's not a possibility, it's a mathematical certainty. If you have an infinite number of Hubble volumes, those observable bubbles we talked about, but only a finite number of ways to arrange the contents within a Hubble volume, then the exact arrangement of our Hubble volume must repeat. And not just once, an infinite number of times. And since you are part of the arrangement of our Hubble volume, that means you must repeat too. Somewhere out there, far beyond our cosmic horizon, is another bubble of space-time with an identical copy of our Milky Way galaxy. Inside, an identical solar system. Orbiting an identical sun is an identical Earth, where an identical version of your parents met and an identical version of you was born. This person has lived your exact life, moment by moment. Every thought, every mistake, every triumph, they are you in every single measurable way. This is the Level 1 multiverse, as physicist Max Tegmark calls it. Not a different dimension, but simply a region of our own infinite universe so far away that it's causally disconnected from us. A place we can never reach, never communicate with, but which must, by the laws of probability, exist. So, how far would you have to travel to meet your cosmic twin? The calculations are staggering. Physicists have estimated the number of possible arrangements of particles in a Hubble volume. Using that, they've calculated the probable distance to the nearest identical Hubble volume. The number is so colossal, it breaks our intuition. It's roughly 10 to the power of 10 to the power of 118 meters away. Let me be clear. That's not 10 with 118 zeros. That's a 1 followed by a number that is itself a 1 followed by 118 zeros. There isn't enough space in the entire observable universe to even write that number down. It is a distance so profound that it is, for all practical purposes, meaningless. You will never meet this other you. You will never even see them. They exist in a patch of reality that is forever beyond our reach.
There's a famous short story by Jorge Luis Borges called The Library of Babel. It describes a universe in the form of a vast library containing every possible book that can be written using a basic set of characters. Most books are complete gibberish, but because the library is total, it must also contain every great work of literature ever written, or that ever could be written. It contains the cure for cancer. It contains the true history of the universe. It contains a perfect biography of your life. And it contains a version of your biography where you make one tiny change. This is a perfect metaphor for the level 1 multiverse. Out there, in the infinite cosmos, there's not just a Hubble volume that's an exact copy of ours. There's also a volume that's identical except for one single atom being in a different position.
And this is where the idea gets even stranger. That single atom being out of place could be in a distant star, having no effect on your life. But what if it's in your brain? What if it causes a single neuron to fire differently at a critical moment? You decide to take the job you turned down. You decide to talk to the stranger you walked past. You zigged where this other you zagged. Suddenly, you have a near copy of yourself living out an alternate life path. And because the universe is infinite, every possible quantum fluctuation, every possible decision point is played out somewhere. There is a you who is a celebrated artist, a you who is in prison, a you who died as a child, a you who achieved every single dream you ever had. Every possible version of your life story is not just a fantasy. It's a reality being lived out in some distant, unreachable corner of the cosmos. The variations don't stop at your life choices. The logic of infinite space and finite arrangements applies to everything. Somewhere out there, there's a universe identical to ours, except the Beatles never formed. A universe where Shakespeare was a terrible writer. A universe where humanity never revolved, and Earth is ruled by intelligent dinosaurs. And we can go even further. If the fundamental constants of nature are also subject to variation across an infinite space, then there are regions with slightly different laws of physics. A universe where gravity is a little weaker, leading to impossibly tall mountains and spindly creatures. A universe where electromagnetism is stronger, making stars burn out in an instant. The cosmic library contains not just every story, but every possible set of rules for writing those stories. This idea forces us to confront some very deep questions about identity. If there are an infinite number of yous, what makes you, the one watching this video, the real you? You might say it's your consciousness, your unique stream of experiences. But your doppelganger has the exact same stream of experiences, right up to this very second. They feel just as real as you do. They believe they are the unique, original version just as you do. The theory implies that there is nothing physically special about you. Your entire existence, your whole life, is just one pattern of particles in a specific configuration. And that pattern is repeated over and over across an endless canvas. It can feel like it devalues individuality. If every choice you make has already been made by another you, does your choice even matter? This is a profound challenge to the concept of free will. We feel like we are the authors of our own stories. But if every possible story is already written and playing out somewhere in the cosmos, are we really choosing anything? Or are we just experiencing one predetermined path out of an infinite set? It's a dizzying thought. The version of you that makes the right choice and the version that makes the wrong one both exist. The hero and the coward, the victor and the victim, all of them are you. It doesn't mean your choices don't matter for your life, the one you are experiencing. They matter immensely, but it suggests that on a cosmic scale, the universe doesn't favor one outcome. It tries them all.
Now, it's time to pump the brakes. This entire mind-bending scenario hinges on one huge assumption, that the universe is truly, geometrically infinite. And we don't know that for sure. Our best theory for how the universe got so big and flat is called cosmic inflation. It suggests that in the first fraction of a second after the Big Bang, space itself expanded at a rate far exceeding the speed of light. This would have stretched our universe to be so incomprehensibly vast that it appears flat and effectively infinite to us. But incomprehensibly vast is not the same as truly infinite. It's possible the universe is finite, but just so much larger than our observable bubble that we can't detect the curvature. If it is finite, even if it's a trillion times larger than what we can see, then repetition is no longer a certainty. It just becomes an unlikely possibility.
The second major assumption is that there's a finite number of ways to arrange particles in a given volume. This seems plausible, but the universe is strange at the quantum level. Are things like position and momentum truly discrete, or are they continuous? If there's an infinite number of possible positions a single electron could occupy, even within a tiny range, then the number of possible arrangements could also be infinite. Many physicists argue that for the math to work, space-time must be quantized at the smallest possible scale, the Planck length, which would make the number of states finite. But this is at the very edge of our understanding. We don't have a complete theory of quantum gravity to tell us for sure. So the cosmic doppelganger theory rests on two giant, albeit very plausible, pillars of modern cosmology. If either one is wrong, the whole idea collapses.
It's helpful to place this idea in a broader context. Physicist Max Tegmark categorized multiverse theories into 4 distinct levels. The one we've been discussing, the repeating regions in our own infinite universe, is level 1. It's the least controversial because it requires no new physics. It's just the logical outcome of our current theories. Level 2 suggests that cosmic inflation, the process that blew up our universe, is eternal. It's constantly spawning new bubble universes, of which ours is just one. These other bubbles could have different fundamental constants or even different laws of physics. This is a step more speculative. Then you get to level 3, the many worlds interpretation of quantum mechanics, where every quantum measurement splits the universe into parallel versions. And level 4, the ultimate ensemble, where every possible mathematical structure corresponds to a real universe. Compared to those, our cosmic doppelgangers seem almost mundane.
Here's the most frustrating part. This theory may be unfalsifiable. Because your cosmic twin exists outside our observable universe, outside our light cone, there is no way to communicate with them, no way to travel there. The expansion of space itself ensures these other regions are moving away from us faster than light can travel between us. They are, and will forever be, beyond our reach. We can't run an experiment to prove or disprove their existence. All we can do is trust the mathematics. It's a form of knowledge that is purely theoretical, a ghost in the machine of cosmology. We can argue about it, we can calculate the probabilities, but we can never, ever get a definitive, empirical yes or no. And for a scientist, that's a deeply unsatisfying place to be.
So how should we live with this knowledge? It can feel terrifying, this stripping away of uniqueness. But it can also be seen in another light. If every mistake you've ever made is being corrected by another version of you somewhere, and every success is being experienced, it paints a picture of a universe that is complete. It means that somewhere the best possible version of you exists. Somewhere the most compassionate version of humanity exists. It also means that your life, the one you are living right now, is your own. The other yous are irrelevant to your experience. You are the only you that you will ever know. The choices you make are the only ones that will ever matter to this consciousness. This perspective can be liberating. It makes this life, this singular thread of experience in a cosmic quilt of infinite threads, profoundly precious. Your cosmic twin, 100 billion light years away, can't feel your joy. They can't feel your pain. They can't help you or hurt you. They are just a statistical echo in a vast, indifferent cosmos. The person who matters is the one right here, right now, the one drawing breath, the one making decisions, the one capable of kindness, of creativity, of love. The sheer, mind-numbing scale of the universe doesn't have to diminish us. It can also serve as a backdrop that makes our brief, improbable existence all the more remarkable. In an infinite universe of copies, the ultimate act of rebellion is to live your life, this specific life, with purpose and meaning, to make your tiny, unique patch of space-time count. This idea of infinite, repeating universes has an interesting connection to another great cosmic mystery, the Fermi paradox. Where is everybody? If the universe is so vast, it should be teeming with intelligent life, yet we see nothing. The Level 1 multiverse offers a potential, if lonely, solution. Perhaps life isn't rare at all. Perhaps there are countless civilizations out there, but the distance between them, the distance between these habitable oases in an infinite desert, is just too vast. The average distance between civilizations could be so great that they are all outside of each other's observable universes. We might live in a crowded cosmos, but each civilization is trapped in its own isolated bubble of space-time, forever unaware of the others. The great silence isn't because we're alone, but because the neighbors live too far away.
Let's touch on a highly speculative and dangerous philosophical tangent of this: quantum immortality. This idea combines the Level 3 many worlds multiverse with the concept of consciousness. It suggests that your consciousness will always follow the path of survival. If you are faced with a 50-50 life or death event, in one universe you die, in another you live. The argument goes that you can't experience the universe where you die, so your conscious experience will always continue in a branch where you survive, no matter how improbable. You would seem, from your own perspective, to be immortal. This is not a scientific theory. It's a thought experiment with grim implications. You might survive, but you'd be living in increasingly bizarre timelines, watching everyone you know age and die around you forever. It's a terrifying version of immortality.
If we take the idea of infinite time and random fluctuations to its most absurd extreme, we get the problem of Boltzmann brains. The idea is this: in an infinitely old or large universe, it is statistically more likely for a fully formed, conscious brain to randomly pop into existence out of the quantum foam of the vacuum, complete with false memories of a life, than it is for an entire, complex, low-entropy universe like ours to form. It's a reductio ad absurdum argument. If our current cosmological models predict that we are overwhelmingly more likely to be these fleeting, disembodied brains than actual humans in a real universe, then our models must be wrong somewhere. It's a philosophical check on our theories, a warning that our understanding of infinity, entropy, and consciousness is far from complete. The idea of being a copy isn't limited to cosmology. It's also the core of another popular theory, that we are living in a sophisticated computer simulation. In this scenario, you are not a pattern of atoms repeated in space, but a pattern of information repeated in a computer's memory. If a civilization becomes advanced enough to create ancestor simulations, simulations of their past with conscious beings inside, they would likely run billions of them. Statistically, it would then be far more likely that we are one of the simulated consciousnesses than the original organic beings. In this case, your doppelganger isn't light years away. They are just a different instance of the same program running on the same cosmic hard drive. The philosophical questions are remarkably similar. What is identity? Do you have free will? What is the nature of reality itself?
So, is there any shred of evidence for any of this? For the level 1 multiverse, the evidence is simply the flatness of the universe and the laws of quantum mechanics. It's an extrapolation, not a direct observation. For other, more exotic multiverse models, like the bubble universes of level 2, some scientists have proposed we could look for evidence. If another bubble universe collided with ours in the distant past, it might have left a bruise on the cosmic microwave background radiation, the afterglow of the Big Bang. There have been some tantalizing anomalies found in the CMB data, like the CMB cold spot, but so far, none of this rises to the level of definitive proof. Most cosmologists believe these are likely statistical flukes or have more mundane explanations. The search, however, continues.
Let's take a moment to reset and recap the core logic, because it's easy to get lost in the strangeness. The entire argument for your cosmic doppelganger rests on just two pillars. Pillar 1. The universe is infinite. Our best evidence suggests space is flat and extends forever, far beyond the horizon of what we can see. Pillar 2. Matter has a finite number of possible arrangements. Within any given volume, like the space your body occupies or the volume of our entire observable universe, there are a mind-bogglingly large, but not infinite, number of ways to configure the particles. When you combine these two ideas, an infinite container and a finite number of things to put in it, you are mathematically forced into the conclusion of repetition. It's that simple and that profound.
And this repetition doesn't just create exact copies. It creates every possible variation. There's the perfect duplicate of you, living your exact life, unimaginably far away. Then, much closer, statistically speaking, is a version of you that is almost identical, but with one tiny change. Maybe you have one different hair on your head. And closer still are the versions where the changes are more significant. The you that took that other job. The you that married your childhood sweetheart. The you that moved to a different country. An infinite cosmos doesn't just contain your biography, it contains your entire life's sliding doors moments, with every path taken and explored by a version of you.
It's worth acknowledging the emotional weight of this idea. For some, it's exhilarating. It paints a picture of a universe rich with possibility, where no potential is wasted. It's a grand, majestic vision. For others, it's deeply disturbing. It can trigger a sense of existential dread, a feeling of being cosmically insignificant, a mere copy-paste in an endless document. There is no right or wrong way to feel about it. It's a concept that pushes at the boundaries of what the human mind is equipped to handle. It challenges our most fundamental sense of self. And like any great cosmic mystery, it forces us to reflect on our own place in the grand scheme of things.
Will we ever know more? Possibly. Our cosmological measurements are getting better and better. Telescopes, like the James Webb, are peering deeper into the early universe. Projects like the Euclid mission are mapping the distribution of dark matter and dark energy with incredible precision. This data will help us refine our understanding of the universe's geometry. We might be able to measure its curvature, or lack thereof, to such a high degree of accuracy that we can say with more confidence whether it's truly flat and infinite, or just very, very large and finite. We may never be able to see beyond our horizon, but we can get much smarter about understanding the nature of the container we're in. There is another possibility for a finite universe that can feel infinite. It could be finite but unbounded. The classic analogy is the surface of a sphere. It has a finite area, but you can walk on it forever without ever reaching an edge. A more complex 3D version is a torus, the shape of a donut. In a universe shaped like this, if you traveled in a straight line, you would eventually end up right back where you started. In this scenario, there wouldn't be doppelgangers in the same way. Instead of meeting a copy of yourself, you could, in theory, meet the back of your own head. Light could loop around the entire universe, allowing you to see the same galaxy in multiple different directions in the sky. Astronomers have searched for such repeating patterns, but have found no evidence for them.
Let's return to the Fermi paradox and another chilling idea. Maybe the reason we don't see anyone isn't because of distance, but because of time. The great filter is the hypothesis that somewhere along the path from simple life
to a galaxy-spanning civilization, there is a barrier that is almost impossible to overcome. This filter could be behind us. Perhaps the jump from non-life to life is incredibly rare. Or, more ominously, it could be in front of us. Perhaps all advanced civilizations inevitably destroy themselves through war, environmental collapse, or uncontrolled technology. In this case, our cosmic doppelgangers would exist, but they too would be facing their own great filter. The universe could be filled with infinite copies of civilizations that never make it, their brief lights winking out in the cosmic darkness.
This paints a rather bleak picture. An infinite cosmos filled with infinite copies, but with almost all of them doomed to fail. Every possible path is taken. But if the great filter is real, the vast majority of those paths lead to extinction. There would be an infinite number of Earths where humanity succumbs to climate change. An infinite number where nuclear war reduces civilization to dust. An infinite number where we are wiped out by a pandemic or an asteroid. The successes, the versions of us that survive and thrive, might be so rare as to be almost non-existent in the grand tapestry. The universe, in this view, is a vast graveyard of failed attempts.
So why do we find ourselves in a universe that seems so perfectly suited for life? This is where the anthropic principle comes in. It's a simple, if sometimes controversial, idea. It states that of course we find ourselves in a universe that can support life, because if it couldn't, we wouldn't be here to observe it. If there are infinite universes, level 1 or 2, with all possible conditions, then it's no longer a surprise that a life-friendly one exists. We are simply living in one of the rare ones where the conditions were right. It turns the question around. The universe isn't fine-tuned for us. We simply can only exist in a universe that happens to be fine-tuned.
And what is the ultimate fate of all these infinite universes, these infinite yous? According to our best understanding, it's a slow, cold death. The universe is expanding, and the expansion is accelerating. In the far, far future, all other galaxies will have receded beyond our cosmic horizon, leaving our own local group of galaxies isolated in an endless void. The stars will burn out, matter will decay, black holes will evaporate over trillions upon trillions of years. The ultimate fate of the universe is to devolve into a thin, cold soup of stray particles and radiation, approaching a state of maximum entropy known as heat death. Every story, every life, every copy of you will eventually end, dissolved back into the cold, silent, infinite expanse. But there is one final, mind-breaking twist. Poincaré recurrence theorem states that any closed system will, given enough time, eventually return to a state arbitrarily close to its initial state. If our universe, or a patch of it, can be considered a closed system, and if it lasts for a truly staggering amount of time,
The random motions of those final cold particles could, by sheer chance, eventually reassemble themselves. The time it would take is beyond comprehension, far longer than the time we calculated to find your doppelganger in space. But it suggests that even after the heat death of the universe, the story might not be over. In the infinite expanse of time, perhaps even the universe itself is a repeating pattern.
We've traveled from the edge of our observable universe to the philosophical abyss of identity and back again. The theory of your cosmic doppelganger is a beautiful, terrifying, and elegant piece of logic. It takes what we know about the cosmos and follows it to a conclusion that feels like it belongs in a myth. But whether you have an infinite number of twins or you are utterly, cosmically unique, it doesn't change the reality of this moment. It doesn't change the fact that you have one life to experience. This one, the one where you are listening to these words.
The universe is either large enough to contain every version of your story, or it's not. Either way, the responsibility for writing this chapter falls to you. The next time you look in the mirror, remember the silent, distant twins staring back from across the cosmos, and the infinite variations living out lives you can only imagine. It's a humbling and awe-inspiring thought, but now I want to ask you, does this idea make you feel more or less significant? Does the thought of another you comfort you, or does it terrify you? Let me know your thoughts in the comments below. Your perspective is a unique arrangement of thoughts in this vast universe, and it's one I genuinely like to hear.